Hello guys! Sorry, my voice was cracked because I sang a lot a while ago. Okay, welcome to my YT channel. This is again, I am a singer, eternal voice, a YouTube content creator. Oh my God. Okay, so this is again my CHE diary. Okay, so our topic for this moment in time is Arrhenius equation. So what do you mean by Arrhenius equation? Actually, this is only one of the topics of physical chemistry, and there's a lot of topics. I will just state now the topics we will be able to discuss in a long period of time. Chart, a long period of time. Oh my gosh, where's that? It's lost. It's here. Okay. It's here, right? I'll do the list for this. Okay, I'll do the listing. Okay. Okay, this is physical chemistry. So the first is the chemical kinetics, electrochemistry, quantum mechanics, spectroscopy, thermodynamics, polymer chemistry, statistical thermodynamics, atomic structure, gaseous state, solid state, liquid state, and solutions. Okay? And there's a lot of equations to be used also somewhere along the way. Okay, but for now, we will focus for Arrhenius equation. What do you mean by Arrhenius equation? Okay, of course, if we have the Arrhenius equation, we have the corresponding Arrhenius theory. Okay, before having the Arrhenius equation, because it's impossible to have an equation without their scientific research. Okay, their principles and theories being discovered, something like that. But in here, Arrhenius equation discovered this Arrhenius theory on 1889. Okay, his complete name is Mr. Svante Arrhenius, capital Svante, Arrhenius. So I don't think so high the Arrhenius theory of acidity and basicity in general chemistry. Okay, to determine the how acid or base the substance really is. This is also Arrhenius theory there. Okay, I don't know if it is related. But in here, it talks about more on the chemical reaction. Okay, there's a chemical reaction, then we have to determine the rate of the reaction. Okay, before going to two problems to be solved, I need to give an overview what is this Arrhenius equation all about. Okay, this describes the reaction temperature. Okay, for many, should we say, physical and chemical reactions. Okay, like that. So this is really proportional. The reaction rate constant. Okay, what do you mean by reaction rate constant? Okay, of course the reaction. Then if it's a rate, then there's a time involved in it, a period covered. Okay, as what I told you a long time ago, if it is talking about a rate, there must be a time in the denominator. Always. It could be second, it could be minute, or anything you wanted to. It depends on the kinds of problems you're be able to solve. That's the rate all about, right? It's gonna be like that. Okay. And if we try to relate this with current, current or ampere, so it is also a rate, right? The rate of the electrical charge over the time, right? Electrical charge over the time. So that is current or ampere. You remember that one? Or coulomb per second is the current. Okay, and coulomb is the unit of electric charge. So therefore, we conclude that current is equal to the electric charge over the time. So that is Q over T. So that is a current. Okay, something like that. It's the same here. Current is over the time. But here, talking about the chemical reaction. Okay, something like that. And in this reaction rate constant, this is the frequency of collisions. Frequency of collisions resulting in a solution or any reaction in a solution, something like that. Okay, collisions meaning bangga. Okay, the molecules will be colliding with each other. That's collision, right? Bombarding with each other. So if we try to determine the frequency of how often they will collide with each other, the molecules, then we need to determine the time for that, the period, the duration, okay, of the bumping, bombarding, colliding with each other, the frequency of collisions that results in a solution, then that is our rate of reaction constant. Kana kuno siya is directly proportional to the temperature. Okay, if we increase the temperature, if we apply heat, then there will be more of bombarding of molecules and collision in a certain chemical reactions or any solution, something like that. Okay? So that's gonna be the principle of Arhenous equation. So the basic formula that we will be able to use for Arhenous equation is like this. Okay? Oh my God. Di man ilagay ninyo ha kami. Bawang na ninyo if you meet this kind of problem in the examination. Okay? Because there is activation energy, okay, and there is also universal gas constant, chuba chuchu, and then you have also the exponential factor. Exponential factor. Okay. Akong i-write. Ano ba to? Okay. So, gawin mo mga research personal job. Okay. So, guys, if I do this also, I do this more than when I was in college. Okay. This is just partial. When I was in college, I do more than this. Okay. There's a lot of papers, right? But in my college days, sobra talaga, with a lot of books in my bag. Before I sleep, okay, there's a lot of books in my bag. Okay, in the table, like that scattering, so the entropy is increasing. The randomness and disorderness of different materials. Before I sleep, there's a notebook, ball pen, folder, books, like that. It became my culture and a habit when I was in college, from first year college to 5th year college, something like that. Okay. Oh my God. Okay, I have to put now. It's here. I have one sheet of paper. Okay, scratch paper. Okay, so, okay, small letter K ha. Okay. My gosh. Yes, I have a new pen. Ano ba to? Wow. So, K is equal to A exponential negative RT activation energy, okay, over RT. Okay. EA, all types of chemical reactions will not proceed. So this is really a requirement in all the laboratory, in the processes, in different plant processes, and also inside our body. Physiology, the food we intake, there's a chemical reaction there. Okay, biological substances, the sugars, the proteins, the nucleic acid, the steroids, the hormones, okay, the fats, okay, like that. So they're also interacting with each other. So they cannot react without this activation energy that I'm going to discuss about. Only to chemical reactions that we see in the laboratory. Okay, it's universal. It's also applicable in the universe. Okay, the reaction of nitrogen and oxygen to produce an ideal air, right? The reaction of hydrogen gas and oxygen gas to produce water in the lake, in the ocean, in the river, in the creek, and in the water that flows down in our faucet and our toilet is also, okay, like obeying the activation energy. Without this, it will not move. Okay, the phases of water will not move without activation energy. Okay, so that's very clear. Now, okay, this is the equation. Okay. Then if energy, wala kayong jowa. Okay? If you're just staying in your bed, you never go out, and okay, if you're staying in your bed, you never go out and do flirting to anybody else. Okay, if you do a flirt and you see somebody and somebody see you also, that's the time activation energy will magkajowa na dyan ka. Okay, so how important the activation really is, activation energy. So this is the K. Okay, K. Reaction rate constant is equals to capital A exponential raised to the power negative EA. Capital EA na siya ha over right? Ganon. Capital A is the guys, mag-ano ka, we should do differential calculus to be employed here. A little bit lang, slide. Okay. Pre-exponential factor. Okay. And then EA is the activation energy. Oh my goodness. Activation energy. Okay. R is the universal gas constant. Okay. Universal gas constant. Okay. We will memorize at least two values of universal gas constant. The first one, we will memorize the 0.08205 liter atmosphere mole Kelvin. And the other one also is in terms of joules, which is equal to 8.3145 joules, okay, per mole Kelvin. Constant. Okay, if you want to memorize all the universal gas constant, then be ready to have your own computation in a blank sheet of paper. Okay, use the ideal gas equation, the PV in RT, if you really want to memorize. Okay. Before, when I was in college, I tried to memorize a lot of that, but now only two. Why should I memorize all? It will just, headache to my brain cells. Okay, only two. Actually, there's a lot. Okay, like this. Okay, these are the values of universal gas constants R. For example, we'll solve the R for in terms of calorie, right? Then we can do that also. PV in RT. Okay. So standard at STP. So pressure. What is the standard pressure at STP? 1 atmosphere. Okay. Now, then if you want your universal gas constant have also torr, then use the 760 torr. If you want also your universal gas constant to have pascals, then you will use the 101,350 pascals in your PV and RT. I will teach you, okay? Because you can derive that even though you don't memorize, okay? So PV and RT. Okay, so R is equals to PV over N T, right? Solve for the value of R. Okay, this one. PV in RT. Okay, PV in RT is an ideal gas equation that is most widely used all over the world and the most popular general gas equation or ideal gas equation. So in here, we can calculate multiple values of R. It depends on the units of the pressure because the temperature is always Kelvin, capital T, and also mole in the denominator. So all you have to do is to adjust only the pressure and the energy. Okay. The unit of universal gas constant, energy and pressure at the numerator, magaganon siya, or energy in the numerator over the mole and temperature at the denominator. Okay, for example, if I try to compute the, let's say, in terms of liter torr mole Kelvin, we can compute also. Okay, example. We'll discuss a little bit because this is very important as we go along the way in our problem solving. Okay, so sometimes also, di magud siya ihatag per me in this kind of R, your atmosphere, joules. Sometimes they will give another R, especially during board examination. Something like that, they will try to give another R in which we are not used to. Okay, or not popular. So all you have to do is to use this within RT. Since for me, it will be best for you to memorize all the values of R, right? Because it will take time to derive. Like this, I will derive the R in terms of torr. Okay. Let's say at STP. Okay, at STP, capital S, capital T, capital P, meaning standard temperature and pressure. So what is the standard temperature in ideal gas? Is 0 degrees Celsius. Okay, so plus 273.15 Kelvin. So it will become like this, 273.15 Kelvin. Okay, so at standard temperature, which is 273.15 Kelvin. Why I emphasize this? Because if you will substitute the 0 degrees Celsius in your equation, it will become 0 in the PVRT. You cannot solve for the value of R. So I will emphasize that this T is really a Kelvin, not a Celsius. The capital T in the equation. Okay, that's a Kelvin. So anything, if the problem will state Rankine, if will state Fahrenheit, then convert it to Kelvin so that you can use that in the PV and RT equation. Okay, C Celsius, then plus 273.15. Okay, because the capital P means Kelvin. Okay, no other thing. Okay, then capital P is pressure. So let's say I will have pressure 760 torr, because that is also equal to 1 atmosphere, right? Okay, 760 torr. Okay. The torr is not really sikat. The most sikat is 1 atmosphere, 101,325 Pascal, 101.325 kilopascal, 14.7 psi, 1.013 bar, something like that, 760 mmHg. The torr is not really that sikat compared to those units of pressure, but let's try to have a R with contains torr. Okay, like this. Okay. R, pressure, 760 torr. Oh, ganon. Again, actually, you can choose also a lot of volume, right? But be sure you will use the 22.414 liters because this is the volume of gas occupied at a 1 mole of an ideal gas standard temperature and pressure. It will never change. We will just die. This standard temperature will never change generations to generations unless this will be studied again. Okay, this is too much. Decades, 3,000 decades, 4,000 decades past, we still use this even to Isaac Newton. Okay, like this, scientists, and then in the past, in the time of Jacob, Abraham, like Muhammad, still the ideal gas law obeys at 1 mole, 22.414 created at the time.